Today in the AWS Developers Podcast, we're talking about different ways you as a customer, different ways you have to deploy your large language model on your AWS infrastructure, on your cloud infrastructure, EC2, SageMaker, Bedrock. Stay tuned, we'll explain all that. Good morning. Thank you for downloading the AWS Developers Podcast. We are available in all good podcast applications every Friday morning. Please subscribe so you receive new episodes every week. Leave us feedback, comments, thumbs up, little star, whatever is in your podcast application. We love to read your feedback. Today, I'm with Tiffany Suter, Developer Relation. Hello, Tiffany. Thank you for joining this episode of the podcast. And we have not only one guest, but we have two guests, Jermaine and Jared. Thank you for being here. You're both solution architect working with startup in Singapore. And I discovered you a few months ago. You wrote a blog post about how to deploy DeepSeek on EC2. And that triggered my curiosity. I contact you, and that's why you are here. We, Tiffany and I, and the type of customer we are talking with, we are so used and biased towards Bedrock. Bedrock is the way to access a large language model for developer. There is just an API. I don't have to care about anything. Bedrock handles all the nasty details. But you're working with startups, with customers that sometimes want and have a legitimate need or ask to deploy a large language model on their own infrastructure. So why? Why would a customer take care of all these low-level details and deploy a large language model on their?
Yeah, hi Sebastian. Thank you for introducing Jared and myself. So my name is Jermaine and I'm a startup solutions architect based in Singapore. Before we dive deeper into why Jared and I wrote the blog post back in January, maybe I can pass the time over to Jared for him to introduce himself.
Yeah. Hi, thank you for having me on this podcast. I'm Jared. I'm actually a cloud architect with professional services in Singapore. We were happy to join this podcast, and we're here to discuss some alternative methods apart from Bedrock for deploying LLMs on AWS.
So back in January, I think the buzz was all over DeepSeek, especially with the announcements of the DeepSeek R1 models, which are distilled versions of the DeepSeek models. So there has been a lot of buzz around this topic because of the how lightweight these models are and the ability to deploy them on CPU instances without having the need for NVIDIA drivers. And this was a large game changer because until then, GPUs were very necessary for these kinds of deployment. So back then, we saw the opportunity and a gap within the community that there was no information on how we can deploy these on AWS. And back then, we do know that Bedrock is the way to go for deploying these open source LLM models on AWS. However, this was not available on Bedrock yet. So there were a requirement for us to be able to deploy these quickly and for us to react to the new models that are coming out. And therefore, we wrote this blog post on how we can deploy this on EC2 instances. So
that's one of the reasons. The model is not available on Bedrock. I want to deploy the latest shiny model from someone else on EC2. But when you talk with your customer, what are the other options that you see about why a customer wants to deploy on their own?
So we do have a few methods of deployment for us to host our own models on AWS. One of them is through EC2. The more common one is to access them using Bedrock. And another method that we can use is on SageMaker AI. So why do some customers want to deploy on EC2 instances? There are a few benefits to that. Some of them require data sovereignty and compliance requirements. They need to have full control of their infrastructure. They need a customized environment, and they need to be able to host the data locally on their own VPC. So that is a very strong use case for having their models deployed on EC2.
So compliance, it's another reason.
Definitely.
So availability of the model, compliance, where the model is running, and where the data are going, to keep the data in the security perimeter of your AWS account. Is cost might be a reason as well? I have absolutely no idea. It's a very naive question.
So working in the startup scene, we do have customers being very mindful of the cost of their AWS services. So by deploying on EC2, especially for these two models like DeepSeek R1, we actually are able to go through with the option of using CPU instances, especially with the Graviton type instances that we have over here at AWS. This makes for a really strong cost optimized use case for deployment of LLMs on EC2s.
So you said it, there are three mechanisms to deploy your own custom model or off-the-shelf model, a model on AWS. It's EC2, so you start your virtual machine, you install everything. It's SageMaker and Bedrock with a recently new capability of Bedrock to deploy your own custom model. So let's go into all these three, maybe starting with the lowest level, the most complex, at least in my imagination. It's EC2. What does it take to deploy a large language model on EC2?
So we will first start with talking about how we can deploy on EC2 instances, which is the entire content of the blog post that we have written that led to this conversation. So the first most important step before deploying on an EC2 instance is actually being able to choose the right type of EC2 instance to be able to deploy and handle the demands of the LLMs that we are going to be running on this EC2 instance. So this begs the question, do we deploy them on GPU instances? Do we deploy them on CPU instances? When and where can we make use of Graviton processors for us to run these workloads?
Or Trainium?
Exactly. Yeah. So this really depends very highly on the demands of the use case, as well as the kinds of workloads that the customer is trying to run on this EC2 instance. So in the general rule of thumb, we are able to use Graviton instances as the most cost-optimized deployment option. So I do have some statistics off my head. Graviton 4 is able to provide up to 30% better compute performance compared to other deployment methods, other EC2 instance types. And this allows us to deliver the best price performance and energy efficiency for the range of workloads that we are trying to run on our EC2 instances.
But it means that a GPU is not necessary. I can deploy a large language model on an ARM, Graviton, a CPU, and nothing else.
Yeah, so this depends very highly on the use case and the requirements. So with Graviton instances, we are able to deploy our LLMs on EC2 instances without the use of GPU. This is mainly for jobs that does not require a very low latency, high performance kind of jobs. So for example, if you're running batch workloads, processing them, you don't need your results to come out really fast. You don't need to interact with the user in a near real-time setting. Graviton makes for a very good cost-optimized option for us to host our workloads on these Graviton type EC2 instances.
When you said better performance, it's time-wise, so the inference is faster?
So when I mentioned better performance, I actually mean better price performance. So per dollar that the customer is paying for their instances, Graviton is able to deliver the same amount of performance for less amount of money.
What does it take at software level? From my previous attempt to do so, I remember there is a lot of dependencies to install. At the time it was GPU, so obviously we have to install the driver of the GPU, but then maybe convert some PyTorch library to something else, especially with Graviton. Do you have like a checklist of all the things to install on a Linux instance?
So I do have a lot of my startup customers who are asking for what are the things that we need to be able to, what are the things that we have to set up before we are able to start using these LLMs on our own EC2 instances, which is why we wrote the blog post to have a quick start guide for customers to refer to and to follow step by step just to get an up and running version. So a few items for us to take note is, one, if you are using GPU instances, there will be a need to install the GPU drivers. And two, in terms of security and infrastructure setup, security groups, NACLs, and route tables for routing purposes, networking. All these are things that you have to take note and set up before you'll be able to access your EC2 instance as you would compared to other deployment methods like SageMaker or Bedrock, which may be a little bit more straight to the point because the infrastructure is, that portion is abstracted away for the customers and they'll just be able to access them using an endpoint.
But in terms of software, there are some special Python library to download as well, or you can just grab the model from Hugging Face and then you have an executable that you start and it's magical, or it's a bit more complicated than that, I guess.
So for that, it actually highly depends on the type of model that you're trying to run on the EC2 instance. So different models might have different dependencies, and these dependencies are highlighted within the model setup quick start guides, and this venue is where you look towards for the kind of dependencies you're installing, similar to how you install the dependencies for any other software that you're trying to host.
So yeah, it's a README, and you need to install pip install or whatever package manager you're using, all the dependencies. But running the model by itself, it's not enough. Most of the time, you want an API to interact with the model. So there is also like a web layer in front of it. What is there a standard open source component that you can install, or you need to develop something?
Yeah, exactly. So you would need to build it in the web and app kind of layer as you would with a regular web application. Compared to deploying them on SageMaker and Bedrock, this is abstracted for you. So there are a few ways that we can quickly get started. One of them is for us to use Ollama, which is the method that we have highlighted in the blog post. So we use Ollama and Ollama Web UI, and these are very quick and readily available resources that you are able to find online. They're open sourced, and you can just follow the installation guide and have it up and running on your EC2 instances for you to be able to have a quick web interface for you to interact with the models that you're trying to host on EC2.
How customers are going to manage the scalability if they need more than one instance, and the availability if you need to have 2, 3, 4 more instances? What's the typical architecture? I guess we are going to talk about load balancer, front-end web, and then this is where things start to maybe be really complicated.
Exactly. And I think this is also where the beauty of AWS stands out because of the way it is highly scalable vertically, both vertically as well as horizontally. When we are looking at scaling our application, we typically would look at having them separately running as a web and app instance. We would have these layers scaled differently according to the workload's requirements, and we will typically front this with application load balancers. And with that, we'll be able to set up metrics that allows us to monitor the level of workload that's running within each of these instances. And from there, the load balancer is able to distribute the load towards these different instances. And we are able to go one step higher from there to implement an auto-scaling group. And this allows us to scale up and down based on the demands that come in. And this is cost optimized because when you don't need that level of demands on your workloads, you're able to scale down automatically. And when you have burst requirements coming in, you'll be able to scale up quickly depending on the usage of your EC2 instances and the requirements.
I guess in that case, you need to prepare an AMI, a disk image of the machine, because downloading, installing a large language model can take time. By definition, it's large.
Yeah, exactly. And this allows on this question, we are able to also bootstrap the EC2 instances using user data scripts. And this can help us to, just quickly bring up all the dependencies and requirements, install what we need for the LLMs to be up and running the moment we need to scale out the instances.
If I want something interactive, like an interactive chat, what size, what type of machine are we talking about? Just to get an idea, it doesn't have to be a precise recommendation for customer, but are we talking about a few hundred megabytes of memory or gigabyte of memory? Are we talking about 10 cores, 60 cores. What's the reasonable size to run these things?
This is also a question that we have gotten quite a lot on the field because when customers are just starting to play around with things, they are not very sure what's the right kind of sizing for you to be able to handle the types of workload. So this is very subjective and it also depends on the exact model that you're running on the EC2 instance. So around the topic of DeepSeek, there are distilled versions of the open source LLM. And what we can do is we can take a look at the sizes of these different distilled models, pick one that is of a suitable size. So for us, we actually went with the distilled Quen 14B model. And from there, we actually used the G4DN instance type. And we also benchmark against Graviton 4 processors, Graviton 4 powered EC2 instances, and these are two types of instance type that we can use to get started with hosting such distilled models and getting just a quick web UI up and running for us to get started.
Naive question, what is a distilled model?
Distilled model is basically, as the name suggests, a distilled version of the large language model. So it's able
to... smaller version?
Exactly, yeah. So it has the core functionalities of the larger LLM, the full LLM, and it allows you to run just like a lightweight, smaller sized of the same model, depending on your compute needs and depending on the kinds of use case that you're serving.
But what is the trade-off? If it is smaller, there is something, you're balancing the size versus what? The quality, the latency, the speed?
Actually, it boils down to the number of training data that we have for this model, and these will affect the kind of performance that we are looking at. Generally, it's based on the accuracy of the model, depending on the kind of cases. So we did a test with the smallest distilled model available, and sometimes the results that we are getting is not able to provide as much depth as the larger distilled model that we are looking at. So it depends very heavily on the type of task that you are looking at offloading to the large language model. So if you have a task that is simple, very direct, you are able to use a much smaller model. But whereas if you're trying to handle a much more complex type of task, then you might have to use a larger model. And it's sort of like a process that requires some form of like a tuning. So you gotta just try out different model types to see which one fits your use case the best.
I really like Sebastian's question actually on how do you determine what would be the actual model size required for your use cases? Jamin, would you say that you would take a customer through, say, trial and error, trying to see which model would be the most performant and thereafter determining what would be an appropriate instance size?
Exactly. In an ideal scenario, we do want to take the customer through a trial and error process to look at different types of distilled model and arriving at the type of instance type that will be best suited for hosting the model. And also depending on the customer's requirements for the performance, we'll look at which version of a distilled model to use.
So we've heard actually a lot about the implementation details and the user journeys that you would take when you're interacting with your customer. Any challenges that you like to maybe sound out to highlight or maybe some key takeaways from your journey trying to help customers in this area?
I've actually tried deploying on EC2, and shortly after, we did have the announcements coming out that these DeepSeek models are available on Bedrock. So when I was deploying on EC2, a lot of the issues actually stem from infrastructure management. So as Sebastian mentioned earlier, how do we scale the application? How do we right-size the instance? How do we take care of all the networking requirements? So these were some concerns that we faced in deployment on EC2, especially in the case where the customer actually don't require this full control over their infrastructure and may actually benefit from having the models readily available on Bedrock for us to just call it through an API.
I have a question. I don't know if you've explored this option, but we talk a lot about agents and also multi-collaborative agents working together. Have you tried to, like, I know how easy it could be to make agents collaborate together on Bedrock, but when you do the deployment on EC2, how easy is it to connect two agents, like two different models together? Is it possible? Is it easy also to, like, we have action groups where you want an LLM to be able to perform an action. Have you explored those options? Like, how is it easy to connect the model to a Lambda function, for example?
I actually haven't tried that on an EC2
Okay.
instance, but I would think we would need some out of the box open source orchestration layer on top of
Yeah.
what we are using. So the beauty of Bedrock agents is it abstracts this orchestration layer for us, and it's also really because of how Bedrock makes it so easy for us that I haven't had a need to try my hands on hosting it on EC2 directly.
So we've talked about how to host on EC2. Have you also experienced on SageMaker?
Yeah. So another deployment option would be SageMaker Jumpstart. And this is actually what we also propose to some of our customers as well. Generally, when we are deploying models on SageMaker, that would be fully managed. So there is less overhead for the customers to manage the infrastructure and also doing the maintenance work as well. So for customers that are able to use SageMaker Jumpstart, and if their models are also available there, that would be one of the ideal deployment methods as well. So SageMaker Jumpstart is a hub that offers many different pre-trained models from providers like Hugging Face, DeepSeek. That was also announced that we would be supporting as well on the 30th of January. So it is easy to deploy and it is easy to manage as well. It integrates with SageMaker AI Studio, and there are also, and this would be suitable for customers who want to do a quick deployment of such pre-trained models, and it is great for their prototyping purposes.
So SageMaker it's a fully managed environment where customers don't have to create infrastructure. So all the things we talk about when we were talking about EC2, creating your VM, choosing the right size. Oh, maybe choosing the right size is still there, but you're going to tell us. But installing all the dependencies and the driver, it's done. I don't need to do that. SageMaker do that for me. Tiffany?
Yeah. When we look at the two different options like SageMaker and Bedrock, what would be the pros and cons of choosing SageMaker over Bedrock? Like, how do you decide between the two ways of deploying a model? Because at the end of the day, like, all of the infrastructure is taken care of. So what are the main differences?
Yeah, so it highly depends on the customer's use cases. So we have customers, as Jermaine previously shared, who really need that kind of custom control, full control over their infrastructure environment. So that is where EC2 would be able to provide that kind of flexibility when they're doing their model deployment, as well as managing their infrastructure. Whereas on SageMaker, it is for customers who would like a quick and easy deployment of certain pre-trained models. They want to get up to speed very quickly with prototyping experimentation. So it is super easy for them to do one-click deployments. They have access to a wide range of different other pre-trained models without having to go through the overhead of the actual deployment and also managing the infrastructure. So we've talked about the benefits, and then there are also some gotchas for both methods as well. The first one would be that on SageMaker Jumpstart, it may not support all sorts of custom models and custom model architectures in general. And some models may require very specific instances. And the challenges for an EC2 deployment would be that, of course, there would be manual setup, more overhead to manage the infrastructure as well, and also less integration with managed services, as Stephanie, you shared, for example, agents. So if we are able to get that, in a fully managed way as much as possible, as Jermaine shared, that's why we would push customers towards using Bedrock instead. There are other features like agents, as you mentioned, the orchestration as well. Those would be a more fully fledged and fully integrated solution.
Maybe it's a matter as well of gravity center for the customer. I mean, if they have already their data pipeline and use inside SageMaker and they are used to handle SageMaker, they have multiple users, they might tend towards SageMaker versus Bedrock, which is still relatively new, even if it is now like 1 or 2 years old.
Yeah, and I
Exactly. Yeah.
think I wanted to add on to that as well. So Jared has shared why you would pick EC2 or why would you pick SageMaker. I just wanted to add in a little bit more on the comparison between SageMaker and Bedrock. So just adding on to what Jared has said, SageMaker also gives you the complete control over the entire machine learning lifecycle. So as Sebastian has shared, if there is an entire mature data pipeline that's already been set up in this organization, then SageMaker might be the go-to solution because of these requirements. And it also allows you the ability to train models, fine-tune models, and integrate, let's say, custom code or algorithms if you have these implementations. And this will be ideal for SageMaker use case. And comparatively, Bedrock is a lot more easier to use. It's a lot more managed compared to SageMaker. But the trade-off is that you don't have the access and the control to the said abilities that SageMaker would offer. So we are looking at pre-trained models and managed inference endpoints for Bedrock, and the level of fine-tuning that is available on Bedrock is not as comprehensive compared to how you would do it on SageMaker.
So if I understand you well, on SageMaker you have full control. On Bedrock you have to fit within what Bedrock is offering.
Yeah, exactly.
So we talk a lot about Bedrock as well. Bedrock is mostly known as for a serverless access to off-the-shelf model, but it's a fact that you can deploy add a model that you train yourself or fine-tune yourself, add a model from another provider. You mentioned already Hugging Face, Jared. So what's the customer experience there? I go to the Bedrock console and then...
In this case, there have been 2 recent deployments for Bedrock. So the first one was that much earlier, customers can also import DeepSeek via Bedrock's custom model import feature. And actually just last month, DeepSeek is actually now available as a fully managed serverless model on Bedrock itself. So that makes things even easier to bring customers, to bring this model for customers to use. So there are some distinguishments between the 2 methods. For example, when you're trying to do a custom import job, there are certain things that which we support. For example, certain Mistral models, certain prerequisites that you would have to ensure before you can do the custom model import. Whereas as a fully managed serverless model already available out of the box on Bedrock, that is something that you can just turn on via model access, and users will be able to make good use of the model right off Bedrock and consume it as an API endpoint. So there are some differences as to why you would want to go about going through this approach. Yeah, and that would be the fact that on Bedrock, all of these would be a fully managed API endpoint. There is actually no instance type for you to even take a look at compared to SageMaker.
You cannot
or
even
EC2.
see the instance type.
Exactly.
What are the differences there?
Yeah, so there are also other features that Bedrock also supports that would be fully integrated when we are deploying DeepSeek on Bedrock as well. For example, guardrails, for example, agentic workflows, as Tiffany mentioned. So all of these can be helpful features. So again, I think it's also important for customers to realize what is your exact use case. Sebastian mentioned that if you are already using an end-to-end ML ops pipeline on SageMaker, yes, you will probably be a lot more inclined to having that model being deployed via SageMaker Jumpstart as compared to Bedrock. If let's say you're building agentic workflow features, that might be something that is easy for you to integrate out of the box, and that might be where you might be more inclined towards deploying that on Bedrock. So there's actually another difference as well that needs to be noted, and that would be the region availability. So for us, we are based in Singapore. US and Europe tend to have the features a lot more quicker compared to Asia Pacific. So this is something that this is an angle that we also bear in mind when we are entering these discussions with customers as well, which is basically, is this feature available in their region? So in this case, for DeepSeek on Bedrock, that is actually not available currently in Singapore at least. So that is why we have written this blog post to explore other alternative options while we wait eagerly for for DeepSeek to arrive on our shores via Bedrock. And actually, the feature Bedrock custom model import itself, I believe this is only available in the US and Frankfurt for now. So that's where we have other alternatives available, such as SageMaker as well as EC2.
Yeah, that's super important. Not all the features are deployed in all the region at the same time, especially with Bedrock, because the team is moving so fast, so quickly. So typically they deploy in the US, sometimes in Europe, and one region in Europe, and then in APJ just after. So depending on regional availability, you might choose one or the other method as well. What about the entire environment? Tiffany mentioned agent. I would add RAG and vector database. Most of the time, you don't want a large language model by itself. You need an API, you need an agent, you need a RAG database. This is where Bedrock might be compelling as well. Otherwise, it's a lot of infrastructure for you to manage and to install.
Yeah, exactly. And it's neat that you brought up RAG as one of the main factors on why Bedrock is so powerful, because especially in the startup scene, it's becoming quite challenging for customers to set up a vector database, manage the vector database, and set up RAG for their generative AI workloads. So the beauty of Bedrock is that we have knowledge bases available right out of the box, and it will offload all the heavy lifting of creating and maintaining vector databases. And if the customer does not really have an idea on how to go about trying this out, there are really handy quick start user guides that will allow us to set one up very, very quickly. And we are able to connect different types of data sources that may seem a bit more familiar to our customers, such as S3, web crawler. And these are ways where customers can really get their hands dirty, get started on creating a RAG-based chatbot for their organization.
What about cost? Deploying your custom endpoint on SageMaker or Bedrock can be quite expensive, especially for startups or personal accounts. We are talking in thousands of US dollars per month. So please beware if you want to try that on your personal account. That's the range of of budget that we are talking about. Is there any preferred method if for learning for personal account for the developers that are listening to us?
Yeah, I would say in general, Bedrock would be the way to go. The pricing
Bedrock's
model would be
serverless, to be clear.
yes,
Okay.
exactly. Yeah. So that's pay per inference. There is no recurring infrastructure management cost, or at least for on-demand Bedrock invocations. Whereas in comparison for SageMaker Jumpstart, it is also pay per use, but that would be based on the hours that your SageMaker instance is running. And it also depends on the size of the instance that you're running as well.
Mm-hmm.
And for EC2, that would be something similar. It's also pay per use based on your EC2 instance type as well as your duration.
I think Bedrock was really cool. I mean, it's a great way to prototype. It's when you're a startup and you want to try like a solution or something, and you just want to quickly have not a solution, but quickly have something that would probably look like your final solution, then it's really great to be able to quickly deploy, make agentic workflows, have a RAG, just to test things out and see how things work. In a matter of just a day, you can actually have a full working workflow and then move to either EC2 or SageMaker, depending on your use case. But yeah, Bedrock is a very great way to prototype things.
I think 100% agree with Tiffany on the how easy it is to innovate on Bedrock. And I think it's because it's serverless and it takes away all the heavy lifting that, all the questions that you don't want to answer, Bedrock answers them for you and gives you whatever you want right away, right off the bat. And it's a really good way to get started, play around with the different playgrounds that we have in Bedrock, setting up knowledge bases, setting up agentic workflows, that's very quick for us to get up to speed. And from there, once we have a working prototype, then we can work on identifying the hosting methods that will be best suited for our requirements in terms of data
Yeah, exactly.
sovereignty, in terms of workflows
Yeah.
that we have, in terms of whether we have any existing machine learning workloads. I think that can come after the prototyping is done.
I'm glad that you're telling that, because it seems very similar to what we do with compute. If you want to start early and prototype, you will start with Lambda, and then you will sometimes realize that Lambda is not the right compute service for you, and you need to move back to containers or virtual machine. It's exactly
Yeah.
the same scheme of thought, and I'm happy that we can reuse something that we know already, even in the world of AI and machine learning.
Oh, yes, exactly. And actually, since we are on the topic of cost and about different deployment methods, I think a question that customers usually ask is, how can we optimize our cost? So we do have some guidance over here. For Bedrock, since it's a serverless architecture, that would be our recommended way. Since there's no need for you to provision or manage your infrastructure. You can also reduce your cost for sporadic workloads. That would be one good option. Whereas for SageMaker Jumpstart, usually for development and for testing purposes, customers can consider using smaller instance types, doing things like diligence, shutting down your endpoints when you're not using, to avoid unnecessary charges. And also for EC2 itself, you can leverage savings plans, you can leverage reserve instances for predictable workloads that you have to achieve more cost savings, or maybe in fact, spot instances can also help you to offer up to 90% of discount for interruptible workloads. So we do have different options for you to explore how you can optimize your cost. Again, it goes back really to the use case that you're trying to do over here.
That's a really good insight. To finish this episode, do you have like a decision tree or the key questions that a customer should ask themselves before choosing one option or the other? What would be the starting from the use case probably, and then what are the main factors for a decision?
Yeah, I think at Amazon, we always like to work backwards, and it really goes to show how we will go and ask about the customer's use cases first, trying to understand what are they trying to do, thereafter trying to determine what are the correct models to use, what is the perfect instance type to use, and also the model support for different deployment methods as well. Things like region availability, that's definitely something to consider. Data sovereignty as well, and also the integration for your own other use cases. For example, if you're already using SageMaker, is this something that you want to integrate for with your existing end-to-end MLOps pipeline? Or would it be some custom model that is not available on Bedrock or Jumpstart? That would be something that drives you towards EC2 instead. And also how you would like to have to pay for these services. These are things that we would be asking as well.
Yeah, usually the question that I go into a conversation with a customer is that, are we looking at a proof of concept, or are we looking at having, from the get-go, we want to work on a solution that will be production ready in time to come. So typically customers are looking for a proof of concept for ideas that are, the talk of the town, the trends that are coming up as we go along. So if the idea is to do up a proof of concept, then we can leverage on the most price performant options that we have for us to allow the customers to get started quickly, as well as have the best bang for their buck. So with that, I think that's one of the first questions that I use when I go into a customer conversation. And from there, we can scope down further depending on what they're trying to achieve. Is their workloads interruptible? Are they doing batch processing? Do they need low latency? Yeah, from there, we will narrow down further into the kind of deployment methods to do. Once we have the deployment methods narrowed down, then we will go further into identifying how we are going to go about doing it, sizing the right instance types, or if we're using Bedrock, what kind of models do we want to use, and what kind of additional accoutrements like agents or knowledge bases Yeah, so that will be the workflow that I go to.
That's a fascinating conversation. Thank you, Tiffany, for co-hosting this
Thank you.
this episode. Thank you, Jared and Jermaine. Jermaine, you're a solution architect in the startup team based in Singapore. Jared, you're in Singapore as well, and you're a cloud architect in professional services. That's not what I said at the beginning, and I apologize for that. So we have the data correct. We did an exploration about how to deploy your own large language model on AWS, and we talk about 3 different options: EC2 instance, SageMaker, and Bedrock custom models, Bedrock custom deployment. Thank you for highlighting the different options and the trade-off for all these. I will link to your blog post and more, deploying DeepSeek on EC2, deploying DeepSeek on SageMaker. So if you're listening this episode, you can scroll your podcast application. You will find the link to the blog post that we talk about. Thank you for having listened to this episode until the end. See you next week in your good podcast application for another episode. And now go build.